Welcome to another tutorial under momentum and impulse. We look at tutorial number 1. Question. The goal of this question is to find the impulse as well as an estimate of a force in a collision of a moving object with a stationary object. And in this scenario, our stationary object is actually this object there. All right, that is our stationary object. And the moving object is this car. In a crash test, a car of mass 1.5 times 10 to the power 3 kilograms collides with a wall and rebounds as in this figure here. The initial velocity is negative 15 and the final velocity is 2.6 respectively. If the collision lasts for 0.15 seconds, okay, so that's how long the collision lasted. How do we find the impulse delivered to the car due to the collision and the size as well as the direction of the average force exerted on the car? Let's go. All right, so first of all, let's first collect our data here. Okay, we have the mass of a car as 1.5 times 10 to the power 3 kilograms. Okay, what else do we have? We also have the initial velocity, which is negative 15. And we have the final velocity, 2.6. Also have got the time taken, 0.150 seconds. So this is what we have. So how do you actually answer part A, the impulse? Recall that impulse is just the change in momentum, all right? Impulse is just the change in momentum. And when we say the change in momentum, we mean the momentum final minus the momentum initial. So what we need to find here is momentum initial. And momentum is mass multiplied by velocity. And this case, since we are looking for momentum initial, we are going to use velocity initial. Okay, the mass is still the same, kilograms. I'm going to multiply the initial velocity, which is negative 15. Okay. So let's punch on the calculator. So after punching on the calculator, I'm getting negative 2.25 times 10 to the power 4 kilograms per meter. Sorry, kilograms meter per second. So that is our initial momentum. So now let's find our final momentum. So the mass is the same. So we're going to use final velocity. So the mass is still the same. The final velocity is 2.60. So let's punch this on the calculator. So I'm getting 0.39 times 10 to the power 4 kilograms meter per second. So this, now remember that this one is negative, so this one is positive because you know, look at the velocity. This one is going in the opposite direction. So we take this like our negative x-axis, then the rebound, we take it as the positive x-axis. You agree, right? Meaning even their velocities are as this. Okay, so now impulse is the change in momentum. So it is the difference between these two. So it's the difference between 3.9 times 10 to the power 4 minus. Now look, I'm going to say minus, but remember that this one here already has a minus, so that will be minus 2.25 times 10 to the power 4. Okay. Right, so after the addition, so these are going to add, of course. And I'm getting 2.64 times 10 to the power 4 kilograms per meter per second. This becomes our impulse. Are we there? Now, how do we answer B? B says the size of the force. Now, remember the relationship between momentum and impulse. Well, the relationship between force and momentum is that change in momentum is equal to force multiplied by time. Now, in our case, we are looking for force. Therefore, our force, okay, which is average, since we are looking for the average, it's average? Yes, average. So we put AV down here. It will be the change in momentum over the change in time. So the change in momentum, remember, it is just impulse. You see, change in momentum is just impulse. So just put impulse there over change in time. So the impulse found here, it was 2.64 times 10 to the power 4. Okay, over. Then here what we have is time. Time is 0.150 here. And now let's divide. So after the division, I'm getting 1.76 times 10 to the power 5 newtons. Okay. Now, in what direction? Remember, here they also told us the direction. So do you think it is positive or negative? It is positive. Okay. So it will be what? It will be negative. So it will be positive, sorry. Yeah, you've known. And make sure that you subscribe.